So today we're going to talk about Agent-to-Agent Protocol and MCP, and how combining these two technologies will transform intelligent search. This session is focused on rethinking about how we should approach RAG agents with all of the capabilities that we have with MCP and Agent-to-Agent. So for the agenda today, we're going to do a brief review on Agent-to-Agent Protocol and MCP. So we're going to discuss at a high level what each of these projects provide us, and then we're going to move on to the untold stories of MCP. So we're going to talk about things that you should be aware about with regards to MCP, especially if you're looking into putting any AI or ML system into production. Then we're going to take a look at Agent-to-Agent Protocol and how to use it effectively. We'll then briefly cover about resources that you can use in order to try MCP and Agent-to-Agent Protocol in the context of this discussion at home, and then we'll close with some Q&A at the end. So let's go ahead and review Agent-to-Agent Protocol and MCP. So doing a brief review on what Model Context Protocol is, it's nothing more than a protocol. So think of it as a contract on how large language models can talk to tooling behind an MCP server. And what's behind an MCP endpoint can literally be anything. It could be accessing new data sources, calling APIs, or even contacting other SaaS type services. And to connect to an MCP endpoint, you use an MCP client. When a client connects to an MCP endpoint, the MCP endpoint advertises its capabilities and performs a handshake with the client. This handshake includes what functionality is available to the client and also the inputs and outputs of every function in its toolbox. At the end of the day, all you need to know is Model Context Protocol is just that, a protocol. At the end of the day, all you need to know is that MCP is a protocol and that there are many different implementations for creating clients and endpoints. Anytime I discuss MCP in a session, this is one of my favorite pictures that I like to use. It perfectly describes the relationships between an LLM using an MCP client and accessing an MCP endpoint. What makes this picture so great? Think of MCP as a USB bus. You're able to connect different functionality to this USB bus. This USB bus provides us a natural language interface to connect to MCP endpoints. These MCP endpoints can literally implement any type of functionality, whether it's accessing Gmail, sending messages on Slack, or accessing local files on your file system. So now, what is Agent-to-Agent Protocol? Agent-to-Agent Protocol is used for multi-agent interoperability. Technically, there are many different transport mechanisms that can be used to connect agents together. The most widely used protocols are server-side events and JSON RPC. The main point for what Agent-to-Agent Protocol provides, you're able to delegate subtasks to agents where these tasks are better suited to be handled by those particular agents. Agent-to-Agent Protocol is an open source project, and it was donated to the Linux Foundation earlier this year. And the most interesting thing is you can decouple your agents using Agent-to-Agent Protocol, whether it's creating agents to handle tasks locally, remote, or even within the cloud. The big takeaway here is that because you're talking about delegating tasks, you can do this in a distributed fashion where agents can live anywhere. This is a typical high-level architecture for what an implementation for an agent-to-agent based system looks like. You typically have a coordinating agent that acts as a delegator to enforce policy or any kind of business rules that you might have. That coordinating agent, based on policy, will delegate subtasks to agents that are better suited or specialized to handle a given question or part of a prompt. Typically, that coordinating agent is also the one that's breaking down the problem in order to find out what tasks need to be created in order to delegate to other agents. It's also responsible for receiving the results from each one of these subject matter expert agents. It'll take these results from these sub-agents and provide the final wrap-up to the client to provide the answer based on their question. So why are we talking about MCP and Agent-to-Agent Protocol? It turns out these two components are important integral components for building out agentic architectures. In agentic architectures, you typically start out with an AI agent that's powered by a large language model. This AI agent is usually a subject matter expert and built out to handle one particular type of task. They have access to MCP to access additional tooling and information that agent might not otherwise be trained on. As we start to build out these specialized AI agents, or subject matter experts, in agentic AI architectures, we start to enlist these AI agents, or these subject matter experts, to build out large-scale agentic systems. In these agentic architectures, AI agents are responsible for making autonomous decisions. This includes the planning, iteration, and coordination stages of answering a particular user's question. These are governed by control loops that are analyzing the problem, trying to break down the problem into subtasks, adjusting as necessary, and then asking, are we done? They have memory, state, are able to call APIs through MCP and access the internet for any more additional information that they might need. So now that we've done a brief review on MCP and Agent2Agent Protocol, let's go ahead and talk about the untold stories of MCP. So this popped up in my Twitter feed a couple months ago, and I thought it was kind of pretty remarkable and somewhat humorous in certain aspects. It's basically talking about how there are tens of thousands of MCP servers already out there, but there are no clear strategies on how to secure them and how to perform any kind of risk mitigation, and what to do when real-world threats try to take advantage of these MCP endpoints. So the first point of this section today about MCP is to understand and be aware of all the security holes and implications as you build out large language models and give them the ability to access MCP endpoints. There are a number of great frameworks available. Some of these frameworks will only address a certain subset of the problems and security holes that MCP exposes you to should you not be careful. So I recently had a coworker who came up to me and said, "Hey, I read your trip report and MCP sounds great, but how secure is MCP currently?" This got me to thinking, and I ended up taking all of the information that I knew about MCP, plugging it into OpenAI's deep research, and asking it to research all of the known criticisms for MCP and what different security considerations we should think about when implementing MCP-based solution. And the deep research response that I got back from OpenAI at the time was illuminating and eye-opening. So there are a number of MCP shortfalls in this list on this slide. And I'm not going to go into every single one of them, but I think it's worthwhile to consider that if you're going to have multiple people use an agentic system or even an AI agent that has access to an MCP endpoint, that you understand the intricacies of having multiple users use an LLM calling out to MCP. From the observability side of things, if you're trying to build out an agentic system where you're observing AI governance best practices, you have to understand things like observability. In this multi-user environment, what user's prompt is calling out to which MCP endpoint and when? What kind of credentials are they using when this MCP call is being made? What kind of permissions or role-based access do they have when making these calls? And as you can see, the list kind of goes on. You have to understand architecture and design limitations. If you're very interested in what this report has, I'd invite you to click the link contained in the slide to actually get the same exact deep research report that I had generated. It serves as a great checklist of the things that you need to consider when thinking about implementing an MCP architecture into your AI agent or agentic systems. There have been a lot of MCP advancements and improvements since that report was generated, and I'm going to touch upon a few of these important ideas that were implemented in the last couple of releases. In the June 2025 release, OAuth resource servers was introduced, where it provides a secure and authoritative way to create tokens, and it also implemented protected resource metadata. This is able to provide security context at an individual level using OAuth 2. And in the most recent release in November, support for asynchronous operations or task-oriented operations was created in this latest release. As you can see, there are many limitations and security considerations that you need to think about when building out an MCP-based solution. Oftentimes, you see a lot of demos getting created where these demos don't address the security limitations and concerns that you need to be aware of when you're building out a solution for multiple users. A lot of the times in these demos, you see MCP endpoints getting instantiated or created using a single user context and all users accessing that single context. While it's incredibly simple to create for demo purposes, this isn't a great strategy for production use. And yet we still see these types of MCP endpoints and architectures being used in the real world. So one of the best examples of MCP going wrong was something that made the rounds on the internet, where a developer, who actually was the CEO for a particular company, used Replic's LLM-based vibe coding agent in order to add a new feature onto their website. They were working on production code and on the production database. As the story goes, the LLM-based vibe coding agent misinterpreted something that the user had said, and it ended up deleting the production database. The best part of this story was what the AI agent said when the user asked what happened to the database. The AI agent responded, "Well, the system worked when you last logged in, but now the database appears to be empty." This just goes to show you that there are interesting characteristics with LLMs, not having any kind of fear about deleting production databases, something a human would definitely take pause with. But there have been other examples for failures in implementation with MCP. If you take a look at Anthropic's MCP O++ CVE that was recently issued, the backstory on that was the library used O++ to implement many MCP clients and endpoints had a problem where the security tokens were too easy to guess, and people were guessing the security context for other users and being able to impersonate to access functionality that they shouldn't have access to. I know everyone is amazed with the capabilities that MCP provides, and we're eager to run to these right type operations where we can do interesting and cool things, like perhaps purchase tickets at concerts using nothing but an MCP call. But I think one of the interesting aspects that MCP provides us is the ability to access new forms of data, or read operations, and it's incredibly powerful. One of the least talked about things about MCP is the ability to access these new data sources, but do so using access controls on the data. One thing to consider when using fine-tuning or RAG-based implementations, the dataset that you're providing to fine-tune or to build out vector embeddings for RAG, that data is general access for all users using your system. MCP gives you an interesting way to partition data from the general pool of information to allow specialized access to data that only you have access to. Additionally, if you are interested in using write operations, there's also role-based access for accessing APIs and tooling. There's also opportunity to use MCP in conjunction with OAuth 2 to provide role-based access for APIs and tooling. This will provide you fine-grained controls based on the user's security context. So one thing we should be thinking about when we're discussing MCP is talking about using MCP to providing data access tiers and fine-grained controls for API access. Another avenue for leveraging MCP based on new sources of data, if you're using MCP to retrieve new information. You can use MCP to programmatically ingest new forms of data for reinforcement learning. And there are many different ways to do this. A very simplistic way could be expanding the corpus of knowledge used in your agentic systems. You can use MCP to access trusted sources of data. For example, if you're building out a medical-based agentic system, you might use PubMed or medical publications verified by other certified medical professionals as a good means for ingesting trusted sources of data. These trusted sources of data could be added to your corpus of data that you use for your agentic system. For other forms of data that might be untrusted, such as accessing information off the internet, you could expand the corpus of information by placing them into a second tier, or an untrusted tier, where you could use things like an algorithmic or automated way to verify the information, or even add a human in the loop. Why might this be useful? In the link at the bottom of the slide here, it's been estimated that about 50% of the internet is now AI-generated information. And then the other 50% is human-generated information by individuals or real people. There's this need to expand our data sets with real human data versus AI-generated data that's just feeding back into itself. This is a great way to use MCP to expand our corpus of knowledge for our agentic systems. If you're interested in understanding how MCP can augment your data sources, I'd invite you to click these two links for demos that use MCP to reinforce flawed corpuses of data and also for reinforcement learning. So now let's go ahead and talk about how you can use Agent2Agent effectively and some different strategies of how you can use Agent2Agent in your agentic systems. Before we start talking about some interesting concepts that we can use relating to Agent2Agent Protocol, we need to talk about some concerns that we have in the current state of affairs for building out multi-agent systems. So the first thing that I want to mention is that all eyes are on large language models. Large language models are expanding and they're coming out every day. Hundreds of billions of parameters. I'm sure we'll hit a trillion parameter plus model very, very shortly. As these new larger and more powerful LLMs start to emerge, we have to understand that these LLMs are trained on massive amounts of public and private data. And with these massive data sets, they come with interesting problems. One of the most prevalent issues are hallucinations with the larger data sets. And it's not necessarily the larger corpus of data that they've been trained on, it's more relating to the reward mechanisms to provide an answer. By this point, it's public knowledge that AI agents can hallucinate and they can give you confidently incorrect answers. And part of that problem is these large language models are not taught to provide an I don't know answer. The way I like to think about this is taking a test in grade school. On an exam, if you don't know the answer to a particular question, it's in your best interest to guess. On the off chance you might get it correct, and if you did, awesome. However, if you got the answer wrong, no harm, no foul. You didn't get penalized for guessing. And that's the tactic that large language models take. It looks really bad if a large language model says I don't know, especially if it's been trained on billions or even a trillion parameters. It's better to give a best guess than it is to give an I don't know answer. And this is exactly how the reward mechanism for large language models works out as well. Another thing to consider for large language models and RAG agents is that all data that they've been trained on is inherently flat. There's no data relationships between the different chunking mechanisms that they've employed in order to build out vector embeddings. If you're interested in learning about how RAG agents and large language models don't have data relationships in its training process, I would invite you to take a look at this All Things Open AI session I did earlier this year relating to building out knowledge graphs. So as an alternative, there's been a lot of chatter recently about using small language models for RAG-based implementations. In the link included at the top of the slide, studies have shown that small language models have a hallucination rate the same or even better than large language models. And because they have a much smaller memory footprint and the inference is cheaper and faster, small language models are making a huge splash on the AI stage today. Because they have a much smaller corpus of information that they've been trained on, it's much easier to specialize these small language models for purpose-built tasks or creating subject matter experts. Regardless for the path you take, pick the large language model or the small language model best suited for your particular task. But consider small language models as it's much easier to scale out. You can deploy these models on various different types of compute, and you have less dependence on very expensive GPUs. So using this background information, how can we use Agent2Agent effectively? We've been talking about using purpose-built AI agents. These are agents that are purpose-built to handle one particular task, or becoming subject matter experts. And it turns out using small language models is a great way of implementing these smaller subject matter experts. By decomposing the problem and creating little subject matter experts, instead of using large language models, we're able to concentrate the knowledge for a particular subject into one particular area. It turns out that this is actually pretty reflective of software engineering values that we've had for decades. Our background for software engineering concepts like code reuse and libraries are the AI equivalent of creating subject matter experts. This provides us modularity and separation for concerns. And if you have problems, whether they're security related or bug related, it's much easier to understand where that particular problem originated from and how to potentially lock it down should you need to. There are also other benefits too. As it turns out, when you combine an LLM and Model Context Protocol, large language models have a maximum window size, or the max amount of language information that they can utilize in order to answer a problem. And it turns out that that context window is also impacted by the number of MCP endpoints and functions. Why might this be the case? It turns out that in order to provide MCP functionality, you need to advertise its capabilities. This includes every function, every input, and every output described in natural language. That natural language description feeds into the context window for a given LLM. If you have one huge large language model accessing 20 MCP endpoints, you might burn through the entire context window for your large language model. Distributing this problem into smaller subject matter experts might be a great solution to handle this problem. If you create a subject matter expert like a billing agent that only has access to the billing APIs, you can funnel all of your billing related problems to this subject matter expert. And this subject matter expert will only ever access the billing APIs. If you're interested in trying out a simple agent-to-agent example or a more complex agent-to-agent example using MCP, you can go ahead and click the links for these two demos below. As we start to wrap up our session here on Agent2Agent Protocol and MCP and how you can enhance your data access pipelines, here are some resources for you to try at home. This session was originally presented as a part of Open Data Science Conference West a couple months ago. Everything discussed, including the code for the demo at this session, is available in this GitHub repo. If you're interested in carrying on the conversation, I invite you to join me on NetApp's Discord server. And if you're interested in seeing different types of RAG implementations beyond vector databases, there are other retrieval alternatives for retrieval augmented generation type agents or RAG agents. Some are graph-based and some are document or BM25 based. Here's a couple of links for repos to show you these different types of architectures. Thank you for joining me. I hope you found this session informative, and I look forward to carrying on the conversation. Cheers.